Today we're going to be performing basic titration. Now, a titration is when you use a certain concentration and a certain amount of a known acid or base to determine in concentration the molarity of an unknown or known acid or base. Now, this is done by the reaction of OH, negative hydroxide ions, and positive hydrogen ions in solution. They react to make water. So, if you add a certain amount of hydroxide ions, which according to the Lewis definition of bases is what bases produce, to a certain amount of hydrogen, which is what according to the Lewis definition of acids produce, you will produce a certain amount of water or a neutral solution. This can be visibly observed by a reaction of bubbling and can be tested through a pH test. For our test, we will be measuring the concentration of an unknown concentrated version of sulfuric acid that has been produced electrolytically. We will be doing this by adding sodium bicarbonate or baking soda to distilled water and creating a saturated solution. From there, this will be added slowly to the sulfuric acid solution until no more bubbling or reaction is observed. Sodium bicarbonate, made up of the bicarbonate ion and the sodium ion, is something known as an alkali salt, where it dissociates completely into a solution and creates 1 hydroxide ion per 1 mole of sodium bicarbonate. Sulfuric acid in solution will produce wait, I just realized something.
Keep recording.
Sulfuric acid has 2 hydrogens. It doesn't ionize completely. We'll figure that out.
First of all, for materials, we'll need some distilled water. This is free from common pollutants, so that'll be better for our reaction. Then we'll need our unknown concentration of dilute sulfuric acid. And finally, we will need some baking soda or sodium bicarbonate, easily purchased from the store. For glassware and other materials here, we'll be using 2 graduated cylinders, one of which is 100 milliliters, the other is 50 milliliters. Then we'll also be using 2 borosilicate glass beakers. This doesn't really matter as much, just be careful with the kind of plastic or other material you use if you don't use borosilicate glass, as sulfuric acid can be sort of corrosive. In addition, not listed here, we use a little plastic stick to stir, and we also use a small scale to measure our mass of baking soda. Here I add about 30 milliliters of the unknown concentration sulfuric acid solution to measure, and then from there add it to a beaker to perform the experiment. Here, using a cooking scale, I measure out approximately 3 grams sodium bicarbonate. Here I mix my 3 grams of sodium bicarbonate with approximately 81 milliliters of water. We confirm this volume by measuring the solution after in my 100 milliliter graduated cylinder. Once the sodium bicarbonate solution is mixed, carefully add it to the solution of sulfuric acid. As it's added, it should bubble as carbonic acid is formed and broken down into water and carbon dioxide gas. Once no more bubbling occurs, carefully stop and measure the amount of volume of sodium bicarbonate solution you have left over. Testing with a pH strip should show the solution as now neutral. Here I'm writing out the reaction that is going to be taking place in our neutralization. So we have sodium bicarbonate reacting with sulfuric acid. This is going to produce the neutral salt with a pH of 7 of sodium sulfate and also carbonic acid. This carbonic acid should react in the atmosphere to decompose into water and carbon dioxide gas pretty quickly. Earlier, when we measured out our baking soda mass, we got about 3 grams. This is then corresponded to a mole ratio for sodium bicarbonate to determine how many moles of sodium bicarbonate are in our solution. As you can see here, I messed it up a little, so I draw some arrows showing that it's actually reversed. Just use a calculator to calculate this. We're going to round to 3 significant figures here. 3 or 4 should be fine. Then from there, we're able to do further math to show that there is this amount of moles of sodium bicarbonate over that amount of liters, or 81 milliliters of solution, and that gives us a molarity of 0.441. Then here we're going to be doing the calculations explaining how we have 81 milliliters of our 0.441 molar sodium bicarbonate solution, which is reacting with 30 milliliters of an unknown concentration of our sulfuric acid solution. It takes 31 milliliters of our sodium bicarbonate to neutralize this. Here, we're going to be writing out our titration equation. We do this by first writing out the amount in milliliters of sodium bicarbonate solution that it took to neutralize the sulfuric acid solution. As we can see, this is 31 milliliters. We then convert this to the molarity of the sodium bicarbonate solution, and then use the mole ratio of sodium bicarbonate produces 1 hydroxide in solution. This can be gotten from some other more complicated equations for the total reaction. I won't get into that. From there, you can react that 1 hydroxide with 1 hydrogen or hydronium to produce 1 water. Then, because we know this is sulfuric acid, we're just going to assume this produces 2 hydroniums in solution because there's 2 hydrogens attached to it. And we're able to then get to our concentration in molarity of the sulfuric acid solution.
Thank you guys for watching. I know my chemistry was super scuffed and I definitely messed up like a few times. But yeah, leave in the comments if you have any modifications to my procedures or how I can fix stuff and make it better. But yeah, see you in the next one.
Safety glasses off, motherfucker.